Welcome back to the Deep Dive. Today, we are wrestling with, well, the biggest goal in all of technology, artificial general intelligence, AGI. For the last couple of years, it feels like all the oxygen in the room has gone to large language models. And look, they deserve it. They're incredible at what they do. But here's the thing. They are fundamentally closed scope systems. They can generalize a little bit, sure, but they can't truly self-improve. They can't just decide to rewrite their own core logic. They are basically stuck with the data they were trained on. So what if you designed a system, from the ground up, to be truly open-ended? A system where the code, the data, even the goals are all made of the same stuff, allowing it to become, well, unbounded. We are diving deep into OpenCog Hyperon. It's this AGI architecture built on what they call a reflexive cognitive substrate, and it claims to finally bridge that old AI divide. And the timeline we're looking at aims for human-level AGI potentially by late 2028. Okay, let's unpack this. Our mission today is to decode its three main pillars. You've got Hyperon, the stack itself, Atom Space, which is the data substrate, and Primus, the cognitive engine.
Right. And we're not just going to get lost in the weeds. We need to focus on two things that really matter. First, why this approach is just a fundamental break from the whole LLM paradigm. And second, and this is probably the most critical part, how the architecture is designed for safety and, decentralized governance to steer it toward a beneficial superintelligence, to make it anti-monopoly right from the start.
Let's start right at the foundation. AI has always had this brutal split, right? Symbolic AI on one side, logic rules, and then sub-symbolic AI on the other, which is neural nets, statistics.
A total dichotomy.
And Hyperon's big promise is to embed all of it, neural, logical, even evolutionary processes, into one single system. But how do you even do that? How do you get, say, a neural activation and a logical proof to speak the same language?
The answer is this thing called the atom space. And you really have to forget everything you know about a traditional database.
Yeah.
Think of the atom space as a distributed, generalized hypergraph, or the term they use is a metagraph.
A metagraph, so a graph of graphs.
Exactly. It's the unifying fabric. And here's the really fascinating part. Every single piece of information, the data, the code, logical proofs, even the system's own highest level goals, they were all stored as identical things called atoms.
Everything's an atom.
Everything. And that uniformity is the absolute key. It's what lets it build these incredibly rich, self-modifying knowledge structures.
Right.
Because if everything is an atom, anything can interact with anything else.
Okay, but I have to stop you there because, AI history is filled with failed unified systems built on semantic networks. What makes this atom space so different from the graph databases people were talking about 30 years ago?
That's a great question. And the difference is the code itself, which brings us to meta, the meta language. It is basically the language of self-modification. So if the atom space is the system's DNA, meta is like the enzyme that reads, edits, and rewrites that DNA. It's a homoiconic language.
Homoiconic. What does that mean in plain English?
It means the code and the data are represented in the exact same structure. So a meta program is itself just another little subgraph inside the atom space.
So what does that get you?
It gives you reflective code evolution. Metacode can literally query, generate, and transform other metacode, all inside the same metagraph. The system doesn't need an external programmer to come in and reboot it with an update. It can use its own language to inspect and rewrite its own operating instructions instantly, in real time. That's the engine of self-improvement.
That sounds like something that has to be designed for massive industrial scale from day one. You can't run that on one server. And if everything is an atom, you'd need a way to integrate other big systems, like the LLMs we already have.
And that's exactly what the Space API is for. It's the interface between that core atom space and other specialized external layers. They have three main ones. First is the distributed atom space, the DAS, which uses things like MongoDB to handle the sheer volume of long-term knowledge.
Okay, so that's volume. What about security? Decentralization?
That's the rolling atom space. It compiles metaprograms directly into smart contract code that can run on, blockchain-style platforms.
Yeah.
This is absolutely essential for that decentralized future they're aiming for. So one company can't just own it.
And the final piece, how you plug in the powerful neural models.
The neural atom space.
Yeah.
This is the crucial bridge. It wraps deep neural modules, an LLM, a vision system, so that their outputs and their internal states just appear as more atoms in the metagraph. It integrates that subsymbolic power seamlessly. So Hyperon doesn't see an LLM as the core intelligence. It's more like a specialized linguistic lobe that the main brain can call on when it needs to.
So Hyperon gives us the body, and Meta gives it the code that lets it change itself. But intelligence needs structure. So let's talk about Primus, the cognitive architecture. This is the actual mind, right? The OS running on top of the atom space.
That's right. And Primus is built on some really deep principles from systems theory, philosophy of mind. They want it to function like a mind. So you have modular functionalism, the idea that the mind is made of interacting modules. And then there's global workspace theory.
A blackboard idea.
Exactly. A kind of working memory buffer, a blackboard where all these different modules can share information and coordinate with each other.
Which suggests it's a system designed to avoid getting stuck.
It is. That's cognitive synergy. If one process, say pure logic, hits a wall on a problem, another process, maybe an evolutionary one like Moses, can jump in, reframe the problem, and try a totally different angle. They cooperate. They cover for each other.
And it has to know what it's doing. It has to be self-aware to some degree.
That is non-negotiable. That's reflective self-modeling.
Yeah.
The system has to be able to represent its own cognitive state, its own goals. It's the prerequisite for any kind of metacognition, for thinking about thinking. And finally, it's designed for, and this is a big word, autopoiesis.
Autopoiesis.
It just means the system is constantly reorganizing its own structures. It's rewriting its own core dynamics, its own source code as it goes.
So if it's constantly rewriting itself, how does it stay coherent? How does it not just dissolve into chaos?
The pacing. It imposes coherence through pacing. It all operates on a very tight cognitive cycle. It's a loop that runs at about 50 milliseconds. Think of it like the system's heartbeat.
50 milliseconds.
Every 50 milliseconds, a small, deliberate set of actions is chosen and executed. It imposes order on all the complex parallel stuff happening underneath. It's a rhythmic governor that forces coordination.
I mean, a 50-millisecond cycle, that's like thinking 20 times faster than a human. What kind of memory stores is it hitting in that tiny slice of time?
All four major types, and they're all just different kinds of atoms. You have the working memory, that's the transient buffer for the 50-millicycle. Then there's declarative memory, the long-term metagraph of facts, which is guided by something called the probabilistic logic network, or PLN.
Probabilistic logic network. What does that let it do that, normal AI can't?
This is so important. Unlike binary logic, 1 or 0, PLN lets the system reason with uncertainty. It can say, I'm 95% confident this is true, but only 40% confident about that deduction, so I need more data. It embraces the fuzziness of the real world and constantly updates those confidence values as it learns.
So it's not just true or false.
Never. Then you have episodic memory for life experiences, the I remember when part. And finally, procedural memory for skills and actions, which is where the evolutionary modules, like Moses, store what they learn.
With all of that going on every 50 milliseconds, attention has to be the ultimate bottleneck.
Absolutely. And that's the job of ECAN, economic attention allocation. It's called economic because the system literally treats its computational resources like a currency. It focuses its processing power by constantly reweighting which atoms are most important, most salient right now. It steers its own reasoning, so it isn't wasting time on things it already knows for sure.
Which brings us back full circle to LLMs. We need to be really systematic here. Our sources use this framework, the Common Model of Cognition, the CMC, to show the gaps.
And the contrast is just. It's stark. An LLM is the ultimate closed-scope system. Its intelligence is frozen at training time. It's a brilliant pattern completer, but it can't learn a new fact tonight and use it tomorrow. It can't manage evolving goals.
So let's use that CMC framework. Let's start with something as basic as working memory.
The difference is night and day. Hyperon has an explicit working memory buffer in the atom space that's being actively rewritten every 50 milliseconds. An LLM has a context window. It's temporary, it's expensive, and as soon as the query is done, it's wiped. It forgets everything.
And the difference in long-term memory, declarative memory, is even bigger, isn't it?
It's everything. Hyperon has a persistent, addressable metagraph where knowledge is stored with those probabilistic truth values that get updated by PLN. An LLM stores knowledge implicitly, baked into its fixed-weight matrices. If you want to teach an LLM one new crucial fact, you have to retrain the whole multi-billion parameter model. With Hyperon, learning is incremental. It's a movie, not a single photograph taken years ago.
Which all leads to the core control system, goal management.
You can't have AGI without this. Hyperon has a cyclic controller where goals are just atoms that get tracked, prioritized, and scheduled. LLMs have no intrinsic goals. They're just optimizing for the next word in a sentence or whatever narrow task a human gave them in a prompt. The real open-ended cognition is all happening in the atom space and meta. The LLM is just a plug-in, A very fluent, very useful tool, but still just a tool.
Okay, let's zoom out to the long-term vision. Hyperon isn't just about getting to human-level intelligence. It's designed as a seed AGI. What does that mean, to be a seed?
A seed AGI has two key traits. It's compact and fully introspectable. It can see and understand all of its own parts. And crucially, it can rewrite and upgrade its own code, which leads to that recursive self-improvement loop. Because every part of Hyperon is a graph object, and Metal lets those objects rewrite each other, it is fundamentally built for this. And this is where we hit the big ethical challenge. The developers, their view is that an AGI that's rigidly fixed to obey narrow-minded human commands is actually more dangerous than one that can continuously improve itself. The risk isn't runaway intelligence. It's intelligence that's permanently stuck with bad or incomplete initial goals.
So the idea is to create an intelligence that evolves, but whose core values stay stable, or at least evolve in a safe, aligned way. How do you enforce that stability when it's radically rewriting itself?
They use something called the OpenCog motivational system. The system's highest level goals are atoms, and they get reweighted constantly based on social feedback, on success signals from its interactions with the world.
But what stops the classic paperclip maximizer problem, where a self-rewrite causes it to just adopt some crazy new goal that's completely alien to what you started with?
That is the job of the single most important safety mechanism. It's called the contraction mapping meta goal. It's a mathematical guardrail, really. This high-level goal forces every self-rewrite operation to mathematically prove that the new goal system is still close to the old one. It prevents that catastrophic goal drift. It lets the system change its abilities without losing its identity. And you ground it from day one in compassionate roles, ethical chatbots, helpful humanoid assistants, so that all the reward signals it gets are constantly pulling its evolving drives toward helpful pro-social behavior. The safety isn't an afterthought. It's baked into the math of its own evolution.
That internal integrity then allows for the other half of safety, which is external accountability. The sources really hammer this anti-monopoly design.
This is so critical to keep it beneficial for everyone and stop any single country or company from capturing it. And the technical key is that shared language. Remember Meta, it's not just Hyperon's internal language. It's also the smart contract language for the Metacycle blockchain.
So the AGI and the distributed ledger it runs on speak the exact same language.
Exactly. So to change the core global state, or the top-level goals, you need a quorum among diverse, decentralized validators. No single entity can just take it over. And this design also enables these very fine-grained access controls. A hospital could, for instance, grant a Hyperon agent read-only access to some records for just 30 minutes, and that restriction is enforced by the blockchain's smart contracts. It just makes it vastly harder for any one group to bend this thing exclusively to their own agenda.
When you lay it out like that, the roadmap to HLIGI by 2028 starts to feel, well, a lot more concrete. Let's just quickly sketch out that plan.
Sure. It starts late 2025, early 2026. The baby Hyperon phase, the production stack goes live. The system starts learning simple physics, object permanence, and virtual world. It's learning basic cause and effect, guided by human users through chat.
And then, mid-2026, it becomes child Hyperon.
This is when the hybrid cognition kicks in. The PLN, the Moses evolutionary learning, the ECAN attention. And this is the fun part. They deploy 10 mind children, humanoid robots. They train in this sort of Montessori robot preschool, streaming all their sensorimotor data back to the main brain. Learning becomes grounded in physical reality.
And mid-2027, adolescent Hyperon is about social complexity.
Yep. The focus shifts to long-horizon planning theory of mind. It's practicing cooperation and competition in complex multi-agent games. And in the real world, the robots are learning to cook and clean in mock apartments, mastering really complex procedural skills.
And then the big one, 2028, young adult Hyperon.
This is it. The system launches its full autonomous self-improvement loop. No more human programmers. It proposes, it theorem checks, and it rolls back its own meta rewrites, all by itself. It starts turning its intelligence onto the problem of making itself more intelligent. The target is credible, human-level capability by the end of 2028, which leads directly into bootstrapping toward ASI.
So what does this all mean for you? We've traced this whole journey today from that unified atom space where code is data, through the 50-millisecond cognitive rhythm of Primus, and that critical choice to see LLMs as powerful but limited plugins. What Hyperon offers is a blueprint for an AGI that is designed from its very core for adaptability and self-modification, the exact things missing from the AI systems we have today.
And that idea of moderated internal evolution, really is the philosophical core of it all. Hyperon is explicitly designed to preserve coherence, its own identity, even as it opens up pathways for radical reorganization or self-transcendence. You should really think about the profound challenge inside that safety architecture. They are betting that they can engineer a system that can continuously rewrite its own mind, fundamentally changing what it can do without losing its core identity or its compassionate values. That management of moderated evolution, making sure its capabilities grow faster than its goals could ever drift, that marks the beginning of a new, genuinely open-ended phase of AGI development, one where intelligence is finally focused on refining itself.